Hello, everybody. So last year I gave the first one, and this year I give the last one. That's nice. So my name is Timo Derstappen, and as Peter said, I'm CTO of Giant Swarm. I just want to tell you just a little bit what we do. So we are managing Kubernetes 24/7 in the data centers of our customers, and the data center of our customers means we do this in their cloud accounts and also on premises on bare metal. And so we set up our infrastructure in their data center, but we are also running them. So we are on call if the clusters do not work. And we continuously ship into those installations. So we have a pipeline that builds our product or the services, the new Kubernetes versions, etc. And then they're automatically installed in those installations. And yeah, that's all the marketing stuff. And that's us. And we're completely fully remote. I think we're 10 countries now, and people are sitting in co-working spaces or at home, like I do most of my time. But then sometimes we meet all together. So we went to Winterberg and to do some snow fun. We actually did biathlon, shooting, and Nordic skiing together, which was a lot of fun. And yeah, you can see the team is amazing. It's a lot of fun to work with them, and especially the guy that is with the Kubernetes shirt. So what do I want to talk about today? Microservices. Kind of my hair goes up when I hear the term microservices nowadays. Kind of, a little bit. I'm still talking about them, trying to not talk about them as a buzzword, but fill them with a little bit of life and why we doing this and why this is important. And then I go step by step through like how microservices are operated and what kind of things you need to do in microservices, and how the cloud native stack nowadays helps you doing this. As I said, microservices, when somebody mentions it, I'm just like, yeah, don't talk to me anymore. Still, I want to tell you a bit about the goals as I see them, and why I have learned that they help us in the engineering. It's mostly of like I want to have ownership in a team that they can do what they want to do, and they are not blocked by what the other teams are doing. I want to have engineering teams. They work on their stories, and they can ship all their stuff, and they don't have to wait for anybody else. Right? That's very important, and that's also why you can iterate faster, because the responsibility is in the team, and the team can just take their own decisions, and it's just faster in developing things. And that also means that you can experiment a lot more. So you can do every day. You can do some experiments. You can do some tests, and within the metrics you gather within like a couple of hours, you already know a lot more, and you can take better decisions if you do that. And yeah, obviously, if you have applications that run around the globe 24/7. These need to be resilient, scalable systems, and it's not one machine in the basement that operates the software of your company nowadays. And yeah, how do we do this? We break down the services into small services, and we try to have them loosely coupled. We have clear interfaces. Other things you probably heard 10,000 times before. And you definitely need to have a fully automated pipeline if you do microservices. The challenge is that the complexity that you had before within a monolith where you write code in different modules is not going away with microservices. You have a network in between that makes it more complicated, let's say, but in general the complexity is just going one layer down. You have a platform that operates your microservices that takes away some of the complexity for you, but the complexity is still there. So what you need to do to create this kind of infrastructure and this kind of platform is you need to standardize a couple of things. You need to have a way for your teams to do the automation, and you need to have a solution for monitoring and logging. I mean, you can like give the ownership to the team to decide everything, but then again, you like reinvent the wheel a lot of times within the company. That probably doesn't make that much sense, and also, yeah, I mean, ownership and freedom is nice, but I think people are faster if they can just like think about the business logic and the real problem they're solving, and not thinking about like 10 end directions of the problem. Because I first have to solve like how do I do automation. Second, I need to solve how I do monitoring and logging, and so on and so forth. I mean, if we are talking about a team that is like 2 pizza, typical like six engineers. That's kind of not the goal, right? So yeah, you need to standardize that across your teams. Also, the communication between the services, because you know, service A from team A is talking to service B from team B, and somehow they need to understand each other, and yeah, and standardize how you actually like get into the platform, get into your services, and debug them. And if that's all similar, people are much faster. So a platform, that's also a thing that I really don't like. A platform is a platform as a service that has opinions and like locks me into something, and I don't want to have that. I want to have the freedom. So how are we dealing with that? Yeah, it's still a lock-in. Whatever you do, I mean, if you go to AWS, if you use Kubernetes, it's for sure a lock-in. But the question is if it still lets you take your own decisions. You don't. You're not forced into a workflow that doesn't fit your company. You still have flexibility to design that. For me, at least, the cloud native stack, which is the tools that are kind of in the cloud native computing foundation, is giving me that I still have the feeling that I can decide a lot of things, or the things that are decided for me make sense, right? If I have to work with the platform where I always think I have to work around things, then it's really standing in my way. But I don't have that with a lot of those components, and that's what I'm also trying to explain a bit within the talk. So yeah, so what I said before, you need to standardize things. There are much more projects, and there are also some options, but I've chosen them here. So for the automation part, we have Kubernetes. For monitoring, for metrics, we have Prometheus. For logging, we have Fluentd within the foundation. For communication, we have istio as a service mesh, and for debugging, we have, for instance, Jaeger, which is from Uber, which adds tracing capabilities to this stack. And there have been other ecosystems within, the microservice world, and they're also trying to adapt to, all the new tools. And I don't know if you're more familiar with them. I'm not that much familiar with that. And but obviously those have been inspirations for creating the new kind of ecosystem. So who of you is using Kubernetes? In production? Yeah. Production? I hope you heard a lot of talks about Kubernetes and somehow have a picture of Kubernetes now, because I'm not explaining Kubernetes too much. What I want to explain is one fundamental principle within Kubernetes, how Kubernetes works, which is Kubernetes has controllers, and those controllers constantly take care that what you defined within Kubernetes. So Kubernetes has a lot of resources, and the resource is, for instance, a volume, a container, an ingress which defines an incoming request to your services. You can define a service. You can define a lot of things within Kubernetes, and they are called resources. So you define them, and they are stored in a consistent store that allows you to see what I defined. That's my infrastructure. I defined this infrastructure. And the controllers are taking care and to transform your definitions into the real world. I mean, you define there should be 5 containers, and the controller takes care to create those 5 containers. And if you kill one, the controller would see that and create another one. So it constantly has this loop of checking what's going on in your infrastructure and takes care of that, which is different from other automation tools where you like have something that we run as a CLI command and then it creates your infrastructure. But what happens if something goes down? Nothing, right? Maybe you have it in your CD pipeline, and you merge some changes, and those changes are applied automatically to your infrastructure, but you don't have anything that is like constantly watching. I mean, there might be other tools out there that are doing similar things, but in general, I think that's an important difference, and it's a fundamental principle within Kubernetes that you have these kind of controllers. And an operator, a so-called operator, because that's nothing else than a controller, but it's just a fancy name for it because it's basically implementing things that operators have been doing before. It's a way to extend Kubernetes, so you can write your own controller within Kubernetes. And if you want to give it a fancy name, it's operator. So you can create your own like Elasticsearch operator or an operator for your shop system, or for any kind of abstraction that you're dealing with. So for instance, we have a certificate operator. So we need a new certificate. So we create this the definition of a certificate within Kubernetes, and then the operator sees, there is a demand for a new certificate, so it creates a new certificate. And so the operator works with a concept called custom resource definition. And you can create those custom resources. So you can say, my custom resource definition shop, and the attributes of the shop are color, URL, or theme, or something like that. And then you write code that would react if somebody creates a shop entry, a shop resource within Kubernetes, and then your operator would go, I need to have a MySQL container, I need to have my, I don't know, Ruby container, and then I need an Nginx in front. And so that's a way how you can extend Kubernetes to have your own concepts within Kubernetes. And since we are doing a lot of infrastructure, we need this kind of pattern within our services a lot, because it's just a way of having a highly available job transaction that you define. So I define a state that I will make. I want to make sure that this is like constantly applied and constantly taken care of. It's like you operate 10 machines, and then your monitoring tells you, hey, pages you in the night. One machine is down. Then you need to get up, get there, and look how to get the machine back. And that's what the operator is doing for me, right? And if you do infrastructure, that's a pattern that you're using in a lot of cases. And yeah, as I said, we have a Cert operator that does something like that, where you can define the certificate resource, you define the common name, you define some other attributes, time to live, those kind of things, and then you create the resource within Kubernetes, and the operator actually goes to HashiCorp's vault, creates the certificate, and then stores it in Kubernetes as a secret, so that other services can use the certificate within Kubernetes. And if the certificate is deleted, the operator would see that, oh, I have a definition here, but it's actually not there. So it would create a new one and replace, or that's the way how you could, in theory, replace it. And if you remove the definition of the certificate, the operator would also take care of removing the secret from Kubernetes afterwards. Another thing for the automation is you don't want to just have a deployment definition in Kubernetes which defines how many containers you would like to have running and which volumes they are using, but you probably have a lot more resource definitions, so-called manifests, that define your services. And for that, we have Helm Charts. And the interesting part of that is it's not only a collection of manifests, but also it adds templating. So if you want to have the same kind of service running in a test cluster or in a test namespace and development namespace, a staging and a production namespace, you can just use the templating that Helm offers for you. And Helm has a small daemon running within the cluster that actually deploys a service. So that's another thing. How do you get a service deployed into Kubernetes, and how do you define such a service? And yeah, currently it's actually the Helm Summit. It's today and tomorrow, I think. And yeah. For us, really interesting is that they are now discussing to make Tiller an operator. And if you think of an operator constantly taking care that something is deployed in your cluster or something is running in your cluster, it's just a natural fit that Tiller, who is creating an application within your cluster, becomes an operator, because at the moment, if you do something to that service during its runtime, I mean, if you delete a pod, the deployment will take care of replacing the pod. But if you remove the deployment, nothing will be there. But Tiller actually knew that you installed the Helm chart within the cluster, and Tiller should actually also replace the deployment and constantly check that the applications that you defined for your cluster are actually running. And you could even export what kind of things are running in my cluster and apply it to a new cluster and give it the resources for Tiller to recreate the same kind of applications in another cluster. So that's interesting, and that's probably coming up, and we are waiting for that desperately. Yeah, and for the services, for the service definitions, the charts, you also need to have a registry. So not only a container registry, but also you have a cloud native registry where you can store those definitions. And for instance, Quay.io offers that, that you can store the Helm charts within Quay.io, the application registry of Quay.io, and then you can use a plugin in Helm to use that. So within your pipeline, you can create these, you can update your registry, and you can have release channels in there, and then you can subscribe to them. You can say like, okay, this is like my stable channel, and I want to have the stable version of my service deployed here. And that's what we are basically doing. So whenever somebody merges a pull request in GitHub, we have an agent. We currently need this agent to talk to Tiller because there are some functionalities, as I mentioned, missing in Tiller. So first of all, if something is merged, it goes down to our CI system, and then it would run the test, the build, and stuff like that. And then the container would be pushed to Quay, and also the Helm chart definition would go to the application registry. And when that is ready, Circle CI creates a GitHub deployment event, and the daemon called Draughtsman that is running within our Kubernetes clusters is watching the GitHub events. And once there's a GitHub event, it would actually tell Tiller to install the version of the Helm chart that is in the registry. And that's the way how we do continuous deployment within Kubernetes with the tools that are around Kubernetes. And just as an outlook, we're currently working on that to change that a bit because, yeah, Draughtsman is also not an operator. We want to have it as an operator. It's somehow overlapping with the functionality that the Helm team is working on, but we don't know when it's shipped, and we really desperately need that. So we can kind of orchestrate the updates because we have a control plane that manages many Kubernetes clusters, and we need to update all of them. We need to keep them up to date, and we want to have this operator running in all the clusters, taking care that the latest stable version of all our services is deployed in all the clusters. So stepping back out again, so microservices, I explained like how we get those microservices into our production clusters, how the automation works. And I also explained the for us very important concept of operators, which is not necessarily something you need within your microservices. It's just for us. I mean, I'm not a consultant. I'm not talking generally about all the people using microservices. I'm especially talking about how we are using microservices, and that's where I have most of my experience from. Operators don't necessarily are the most important thing for you, but if you're doing operations, they might be important for you. So stepping back a bit, going back to microservices in general, usually there have been like there are some things you need to do like horizontally across all your services, right? And naturally, people start developing some libraries to help you with that, and that's yeah what Netflix did, and they open sourced a bunch of them. Hystrix, for instance, is one of the famous libraries for something like that. And yeah, and you can find them in like almost every language. And just shortly want to go through a couple of them, or why they are there, and why they are good and why they're not good. So we are doing everything in Go, and that's why I'm focusing on the Go libraries here. But yeah, you have something like GoKit that helps you to actually use some abstractions to create microservices where you have a clear spot in your code where you say, okay, here's my business logic, and then it's some abstraction from transport. So you have endpoints where you afterwards can decide if you want to use HTTP or gRPC or whatever, but it's abstracted. It's not leaking into your business logic. Your business logic is completely unaware if it's HTTP or gRPC. And then you have another thing, which is called middlewares, where you can hook up things like authentication or maybe monitoring and logging, those kind of things that hook into your service. So you have a structure within your service where you have your business logic, where you have the transport and the communication, and you have the middlewares, which is like the horizontal functions that you need across all the services. We've taken GoKit even a bit further because they try to be unopinionated, so some decisions are not taken, and also the structure is not. So we created a boilerplate for us. So the goal was we want to create a microservice within half an hour. So that's called MicroKit. It's just for us, but it's open. You can look at it. It might help you how to use GoKit. It's the way how we use GoKit and a couple of other other libraries. And that's how like all our microservices are created. I mean, if they are in Go, which is 99% at the moment. And yeah, it's just we took some decisions and we created a boilerplate. And out of that, we also created operator kit because we're writing so many operators, and we thought that there's some boilerplate code that we do in every operator. So let's like move that out, and we created a library for it. And that helps us to do the reconciliation, which is the loop that like talks to the API of Kubernetes and does the watching of the resources. Right? And you constantly need to do that, and we have some abstraction for that, and then we define the resource, and you can handle the events, like create, update, delete events that are coming from Kubernetes, where you need to write some code, what it actually should do when a delete event happens of a resource. Like for instance, we gave applicants the task to write an operator to create pingdom checks. So somebody defines a check within Kubernetes, says pingdom should check this URL, and these are the pingdom parameters, and then the operator would go and talk to the pingdom API and create it. So you do kubectl create pingdom check, and then you like directly see how it is created in pingdom. You delete the resource in Kubernetes. It's also deleted in Pingdom. We also have a library called versionbundle where we define what kind of version a microservice offers. So a microservice, to be independent from other microservices, need to implement multiple versions in some point. At least if you don't want to make other teams jump onto the new version of your microservices right away, and you cannot deploy your service because the other teams need to fix their stuff first. You want to have unblocked teams. You want to have the freedom to release whenever you want. So we created this version bundle, which is like basically a definition. This is my version, and I have a couple of dependencies to other services in certain versions. And then we have our API gateway, which actually automatically creates the versions of the API of all the services that are there. So you can release a new version of a microservice, and it wouldn't be used at all, but it's there. And then if all the dependencies are fulfilled, automatically the new version of the API would become available. And so we keep them in a way separated from each other, and still nobody has to like do a final deployment of announcing our new API. Once every service is there, the API is available. If you remove one of the services, the API would not be available in that version. So nobody has to do like an additional configuration or additional And we did this because we're supporting so many versions of things. So we support Kubernetes 1.8 with Calico 3.1 and etcd and Docker, and there's like a whole list of things that are in there. And we also need to support transitions from those like to newer versions, and yeah, that drives you crazy in one way, and that's why we created the version bundle library that helps us with that. But to make it short, you should minimize this kind of way to have functionality across microservices, because the more code you write in libraries for one language, the less you can use any kind of other language, which might be useful because, I don't know, to interact with Hadoop, you would like to use something in the JVM and not Go. And also what to do with third-party software. You have components that are running that should react the same way within the dynamic environment of your cluster as all the others do. And if you just have this as a library, it's not a good idea. And yeah, and you also have legacy things that you would like to run in a cluster. So try to stay agnostic, and all the steps within your build pipeline and your monitoring, everything should be independent of a specific kind of technology. And that's why I came up with a couple of patterns to stay autonomous. And yeah, first of all, try to make your service self-sufficient. So you expose things to others, and others can consume those things. And that makes you very flexible. Prometheus is a really good example for that. Like the first place I heard this, I was like, yeah, okay, I have been through this, like pull versus push, and why do we now have to do pull again? But it absolutely makes sense in a cluster world for scalability, and also being able to just expose this metrics endpoint makes a lot of sense. Yeah, sometimes I want to just push some metrics somewhere. I still have the feeling, but metrics endpoints make a lot of sense in many cases with containers. And yeah, provide your versioning information, those kind of things, and yeah, use circuit breakers and use exponential backoff to be independent of sub-services. So if something else is down, you're not affected, you're still working. I mean, maybe some functionality is missing, but you shouldn't like fall down, so you don't have cascading failures within your cluster if some service is down. That's what makes services autark. And yeah, for us, as I said, operator pattern is really important to have this kind of asynchronous feedback loop. So somebody defines something, and I can like our API can give back feedback, say, okay, resource created or resource creation in progress, something like that. But then something else starts kicking off and does a lot of these retry logic. Even if, I don't know, an AWS instance came up and it failed, it can like do this again and try to finalize the infrastructure to the actual state that our users want to have the infrastructure in. So that's why we're using the operator pattern, and then a bunch of container patterns. I don't know if you heard them today already. So there's the Sidecar, which is basically adding some functionality within your pod, but separating it out in a different container. And kind of similar, you can have an ambassador, which is a proxy that you add next to your service that can enrich the communication in a way if it understands the protocol, so it can help you do certain things within the communication, and then the adapter where you can like transform some formats in formats, like if you have a legacy app that offers metrics in a different way, you can still have a Prometheus exporter as an adapter that reads out the metrics from the legacy application and then exports it through a metrics endpoint for a Prometheus. These are typical patterns, and yeah, the challenges we were facing when we were using a lot of those components, because you also start reusing them across a lot of services, is definitely having proper updates for it. It's not that much different from like if you have a security vulnerability in OpenSSL, you also need to roll all your services or many of your services. But still, if you kind of dynamically inject those additional capabilities into your pod, and then you do an update of that, you need to roll all the services, right? And that's it's kind of challenging if things are under heavy development, because then you like roll your whole cluster all the time if people deploy multiple times a day or something like that. So that's a bit of a challenge, but it's not much difference from libraries, because if you have a library and you have the library under heavy development, either they start staling in some of the services that are not constantly updated, or you need to roll all the services all the time. So it's similar, and maybe the composition and having it in a different container even helps you doing this. But still, if you have to roll all the services in a cluster, there's a lot of movement in the cluster. So once again, first of all, we had the libraries, how to create like additional functionality in all the services and all the microservices, and now I try to explain how to do the same thing, but within containers separately and not within the code. And yeah, and now if you have them separated, there are a bunch of projects that help you with this additional functionality within a Kubernetes cluster. So further extending the Kubernetes cluster with more functionality, building more of a platform, I would say. So first of all, yeah, Prometheus, as I said, it integrates with the service discovery of Kubernetes. So easiest case, you deploy a new service, and it's automatically scraped. I mean, that's how it works. And it also fetches a lot of metrics from the objects within Kubernetes itself as well. So you can monitor Kubernetes and all the resources within Kubernetes pretty well. So it's a native fit, I would say. I mean, Prometheus works in other environments as well, but it's really a natural fit, and it's not something else that was developed in a time before Kubernetes that doesn't fit into the ecosystem. It fits very well. Yes, you can use a library to expose your metrics and all your services, but you can also use a container as an adapter, as I mentioned already, to expose, like for instance, the Nginx exporter exports Nginx metrics from an Nginx. So you put them together in a pod right next to each other, and then you have metrics about the Nginx. Yeah, service mesh. So this is actually a lot to cover within the last 5 minutes, but to give you a quick roundup, the service mesh called istio is coming from mainly Google as a driver. It's Lyft, which is like a competitor of Uber is also involved there, and IBM and lots of other. There's a lot of buzz around this, and there will be, I think, 11 talks on Cloud Native Con just about Istio. And you could, in theory, see this as like Kubernetes 2.0 functionality, but separated from Kubernetes in a different project. So it's adding a lot of capability on top of Kubernetes. And I mean, these words maybe give you a good picture. Traffic management means that you can do all sorts of like canary deployments. You can have circuit breaker functionality within the platform, and you don't need it in a library in your microservice. So it does a lot of smart things with traffic. It adds observability, so it adds metrics from all these points where it does the smart routing. It also adds the metrics about the routes, about the connections that are happening and stuff like that. And it also enforces or gives you the capability to have policies around all these things Istio sees. So just to explain it a bit, basically it injects a proxy, an ambassador, into every pod, and it's called Envoy. It's Project Envoy. That's a proxy, and it does a lot of things that you have been doing in libraries before. So it abstracts your transport. So your service doesn't need to know anything about gRPC, but still your services can talk to each other through gRPC with HTTP2. And this is just what Envoy is offering for you. It offers you mutual TLS. So there's istio auth, which creates certificates and an identity for each of your services. And so you have full encrypted traffic, and you know the identity of the caller and the callee. So you can actually do access control for each service. You can do audit logging about what every service is doing with every other service, or what an end user is doing when he calls your API and calls functions within your services. And yeah, so basically, to understand the picture a bit, Envoy is collecting attributes from all the requests, and this is put together in a mixer. And the mixer is kind of like the middleware, so you can write handlers in the mixer that provide you new functionality. So if you want to have an access lock, you can write a handler for an access lock within the mixer that creates an access lock of all your services and ships that to, I don't know, Elasticsearch. These kind of middlewares you can write in the mixer. And your service doesn't know anything about this. It's just happening transparently. The pilot is the service discovery and does all the smart routing. So if you want to do canary deployments, if you want to have a retry logic, those kind of things, this is handled by the pilot. So it's always communication with Envoy, obviously. Envoy communicates with the pilot to understand that the service also somewhere else was unreachable. And then it can do smarter routing because it already knows it doesn't need to try this instance in the load balancing because other services already reported this one down, right? So this kind of logic is in there. And as I said, istio auth is doing certificate management, adding identity, the access control and the audit logging, the audit functionality is coming, and this is just promised. So yeah, I have a bunch of slides regarding that, what I just explained. Yeah, one important thing, don't use it in production because you cannot update it. And if all your services have istio in your pods and you cannot update it without downtime, I mean, this is kind of the thing I mentioned before, the challenge we had with all the composed pods where you add different functionality in like ambassadors or in adapters and things like that. The update is the challenge. And they said, okay, we're working for 1.0, we're working on the update, and then we will have update functionality. But now it's still, I don't know, it's 0.6 or something, yeah. So there's no update functionality, so don't use it in production. But it will be interesting, it will be coming. There's so much hype and big companies supporting it, so I'm looking forward to have that. I also had tracing, but I'm skipping that now, yeah. This is another thing you can add to your cluster as a functionality, and yeah, a couple of other projects. And yeah, just to revisit the goals, if your services are independently deployable, if they can be scaled independently, and if a lot of non-functionality is standardized and reused across, then I think the goal of having unblocked teams and iterate fast is you really just need to focus on your business logic. You need to write a service with business logic, and that's it. All the rest is coming from the platform without too much like enforcing you to use a certain kind of technology. That's the important part, I think. And yeah, and with all the metrics and all the observability within the cluster, I just think that it's just getting smarter and smarter and smarter because a lot of data is coming in there, and also the security that is added to your infrastructure is enormous because you can keep your infrastructure up to date at all time, fully automated, and you have a lot of security concepts built in to the platform in a dynamic fashion that's much more than we had in data centers statically before, in my opinion. So this is really a great win, and thank you.